Less than 100 years ago, humanity believed it lived in a manageable, tranquil cosmos, a sky filled with fixed stars, a stage of space and time where everything unfolded mechanically and predictably. Then the view opened up, and with it, a worldview shattered. Suddenly it became clear, our galaxy is just one among billions. The universe is not static but in motion, not closed but in a state of becoming, not small but unimaginably vast, deep, and dynamic. Yet with this realization came a much larger question. What if the universe is not only expanding but evolving? What if order, structure, and complexity are not mere products of chance? And what if consciousness is not a late accident of matter, but a hint at something more fundamental? In this film, we embark on a journey through modern cosmology, physics, and consciousness research. We follow the path from the idea of a dead, mechanical universe to a radical new perspective, a cosmos that self-organizes, recognizes itself, and perhaps even lives. For perhaps the greatest discovery of our time is not how vast the universe is, but what it reveals about us that we can understand it at all. There was a time, and it lies astonishingly close, when humanity believed it essentially knew the universe. The sky appeared as a great calm dome. The stars were fixed points. The Milky Way was either considered the entire universe, or at least its center. Cosmos meant order, but also limitation. The world seemed closed, predictable, almost complete. This image was not only scientific, it was existential. If the cosmos is small and manageable, then humanity has a fixed place. If everything is static, then meaning seems stable. If nothing fundamentally changes, then there is no need to rethink anything. Yet this worldview would shatter within a few years. The turning point did not come with an explosion in the sky, but with patient observations at a California observatory. There, in the 1920s, astronomer Edwin Hubble began to analyze the light of distant nebulae, those diffuse objects that had until then been thought to be gas clouds within the Milky Way. What Hubble discovered was nothing less than revolutionary. These nebulae were not clouds. They were galaxies. Independent star systems, billions of suns strong, unimaginably far away. And the farther they were, the faster they moved away from us. The universe was not static. It was expanding. In that moment, it was not the cosmos that exploded, but the human worldview. Suddenly, the Milky Way was no longer a center, but a peripheral phenomenon, a spiral system with about 200 billion stars, embedded in an ocean of countless other galaxies, each one a small universe unto itself, each with its own story, dynamics, and future. The sky was no longer a backdrop. It was history in motion. With Hubble's discovery, a new era of thought began. The cosmos became temporal. Evolution entered astronomy. Stars were born and died. Galaxies collided, merged, and formed new structures. Space and time themselves became actors in a vast cosmic drama. For the first time, it became clear we do not live in a finished universe. We live in a universe that is becoming. This realization had profound consequences. And for if the universe has a story, then our existence is also part of a process. We were not born into a fixed framework, but into a development. Our atoms, our elements, our bodies, all of this emerged in earlier phases of cosmic evolution. In exploding stars, in long chains of transformations that span billions of years, humanity was no longer the center of creation, yet we were also no longer a foreign body. We were part of a cosmic flow. However, this new perspective was ambivalent. On one hand, it inspired awe. On the other hand, it bred alienation. The larger the universe became, the smaller humanity seemed. The more dynamic the cosmos appeared, the more random our existence felt. In a space filled with trillions of galaxies, individual life suddenly seemed insignificant. Science provided numbers but no answers to meaning. Size replaced significance, and yet therein lay a hidden clue. For as the universe expanded, something strange happened. It became increasingly comprehensible. The same human brains that had evolved in a savanna were capable of calculating the movement of distant galaxies. The same mathematical structures that described falling apples explained the expansion of the cosmos. Abstract equations fit a reality that spanned billions of light years. The universe was not only vast, it was intelligible. This fact was often overlooked, yet it holds profound significance, for it raises a question that transcends astronomy. Why is the universe even comprehensible? Why do its structures adhere to mathematical laws? Why can a part of this universe, the human consciousness, grasp the entirety of the cosmos in models? Hubble's discovery was thus more than an astronomical finding. It was a philosophical shock. It forced humanity to redefine its relationship with reality. We were no longer mere observers of a small theater, but participants in a cosmic process whose dimensions shattered all previous thoughts. And with this realization began a quiet shift. If the universe evolves, then evolution is a fundamental principle of reality. If structures arise, grow, and perish, then order is no coincidence. If consciousness emerges in such a cosmos, then the question arises whether it is merely a byproduct or an expression of what the universe is doing at its core. These questions were not openly posed at the beginning of the 20th century. Science was busy measuring the new worldview, not interpreting it. Yet the seed had been sown. The old cosmos was dead. A new one was born, dynamic, creative, full of energy and history. The sky had opened, and with it a space for entirely new questions. The moment the cosmos exploded was not the end of certainty, but the beginning of a much greater uncertainty, but also of a possibility. For perhaps a universe that grows, unfolds, and produces structures is more than a machine. Perhaps it is a process, perhaps even a living one. No one yet knew this, but the path was irreversible. Humanity had begun to understand that it does not live in a dead space, but in a universe with history, and every story inevitably raises the question, where does it lead? It is precisely here that the next phase of our journey begins. After the cosmos had lost its apparent smallness, the human spirit sought a new anchor. And the discovery of the unimaginable vastness of the universe demanded order, a model that made this magnitude explainable, manageable, and calculable. And it was precisely here that one of the most influential worldviews in modern history began to take shape, the conception of the universe as a machine. This idea did not arise from a void. It was a response to chaos, uncertainty, and centuries of religious dominion over interpretation. In a world marked by dogmas, divine acts of will, and inexplicable miracles, mechanics offered something radically new: reliability. If nature operates like a clockwork, then everything follows fixed rules. Then there are causes and effects. Then nothing is arbitrary. In the 17th century, this way of thinking took concrete form. With thinkers like René Descartes, Galileo Galilei, and later Isaac Newton, an image of reality emerged that is still deeply etched in our thinking today. Matter was defined as expandable, divisible, and mobile. Mind and consciousness were separated from it. What mattered was the measurable, the visible, the quantifiable. The cosmos became a gigantic machine. Newton described the universe with mathematical precision. Planets moved according to exact laws. Gravity acted uniformly everywhere. The future was, at least theoretically, calculable, provided one knew all the initial conditions. This perspective was so successful that it not only revolutionized physics, but also transformed the entire understanding of the world. If the universe is a machine, then humanity is also a part of it. A biological mechanism, a complex clockwork of flesh and nerves. In this model, consciousness became a byproduct. Thoughts were seen as mere side effects of neural processes. emotions as chemical reactions, meaning as a subjective illusion. The world itself was neutral, cold, value-free. This way of thinking brought about tremendous advancements. Medicine, technology, industry, space travel, all of this would be hardly conceivable without the mechanistic worldview. The ability to isolate and technically utilize natural laws made humanity the architect of its environment. Knowledge became power. Control replaced reverence. Yet this success came at a price, for while the machine functioned ever more efficiently, the world lost its depth. Meaning was banished from nature. Values were regarded as human projections, not as real properties of reality. The universe became a vast, lifeless system that exists by chance and has just as randomly produced life. In this picture, there is no inner meaning, no goal, no direction. Humanity stands before a mute reality that neither knows nor needs it. This perspective shaped not only science but also culture, economy, and self-understanding. Success became measurable, performance quantifiable, efficiency the highest ideal. Everything that could not be quantified, consciousness, meaning, spirituality, was pushed to the margins or dismissed as irrational. The mechanical universe promised freedom from superstition, yet it generated a new form of emptiness. For if everything is merely matter in motion, then love is just chemistry, hope merely an illusion, responsibility an evolutionary trick, and death the final end of all meaning. Many people sense these consequences intuitively, even if they could not articulate them philosophically. A feeling of alienation spread. Humanity became an observer of a world to which it had no inner connection. Paradoxically, this occurred precisely during a time of great scientific achievements. The better we understood the universe, the stranger it became. And yet, it was precisely here that a crack began to show. For the machine model explained movements, but not experience. It could describe how neurons fire, but not why something feels. It could explain evolution, but not why consciousness arises at all. It could measure order, but not why order exists. The mechanical worldview functioned, but it was incomplete. It was as if one had a perfect map devoid of color. Exact, precise, but lifeless. Everything was explained, yet nothing was meaningful anymore. Nature became an object. Humanity became a user. And the universe turned into a stage without inner happenings. This emptiness was long ignored or rationalized, yet it did not disappear. It manifested in existential crises, in questions of meaning, in the growing longing for something that transcends mere function. Even within science, voices began to rise, recognizing that something crucial was missing. For a machine does not explain experience. A clockwork feels nothing. An algorithm does not know it exists. And yet we exist, we experience, we question. The universe as a machine was a necessary step. It liberated the human spirit from dogmatic narrowness. It provided us with tools to understand and shape the world. But it was never the final word. It was a model, not an absolute representation of reality. Over time, its limits began to become visible. For the deeper research delved, the less the universe behaved like a classical machine. On a fundamental level, it became strange, unpredictable, interconnected. Space and time themselves began to waver. And above all, consciousness could not be explained by gears. The mechanical worldview had destroyed meaning because it could never integrate it. It had described order, but excluded significance. It had given power, but taken away orientation. And precisely for this reason, it stood at its own turning point. For a universe that brings forth life, carries consciousness, and reflects upon itself, cannot be permanently understood as a dead machine. The next discoveries would not only complement this image, but shake it to its core. What followed was not a minor error in the system. It was the beginning of its collapse, and with it, the opening to a radically new view of reality itself. At the dawn of the 20th century, the mechanical worldview seemed unshakable. Nature was predictable, the laws appeared known, and many physicists believed that only a few details needed to be added to fully understand the universe. The machine ran perfectly, yet it was precisely at this moment that it began to fracture. The first crack appeared where one least expected it, at the very foundation of space and time. Albert Einstein's theory of relativity posed a radical question to classical physics. What if space and time are not fixed stages upon which matter moves, but are themselves part of the unfolding? The answer changed everything. Space could curve, time could stretch. Simultaneity was not absolute but dependent on the observer. Suddenly, the universe was no longer a rigid clockwork, but a dynamic fabric. Mass and energy influenced the structure of reality. Gravity was no longer an invisible force acting from nowhere, but an expression of a malleable space-time. The machine no longer had fixed gears, it had become elastic. Even more disturbing was that this theory not only convinced philosophically, but was also experimentally confirmed. Light was deflected by gravity. Space and time passed at different speeds depending on proximity to massive objects and their velocity. Reality was relative. Only relationships were absolute. With this, the mechanical worldview began to lose its claim to objectivity. Yet, what the theory of relativity accomplished on cosmic scales, quantum physics completed at the very core of matter. At the level of atoms and particles, the notion of a clear, fixed reality shattered completely. Particles behaved like waves. States did not exist definitively, but only as probabilities. Cause and effect lost their classical clarity. Even more radically, the behavior of a system seemed to depend on whether it was being observed. In the famous double-slit experiments, it became evident that particles changed their behavior the moment a measurement was made. Without observation, they behaved like extended possibilities. With observation, they assumed a concrete state. The machine reacted to the act of looking. A boundary had been crossed that the mechanical worldview could not surpass. For in a classical machine, observation is irrelevant. Gears turn regardless of whether anyone is watching. Yet in the realm of quantum, reality appeared to take shape only in the act of interaction. The observer was no longer an outsider. They became part of the system. Even more perplexing was the phenomenon of non-locality. Particles that had once been in contact remained connected, regardless of distance. Our measurement here instantaneously influenced the state there, faster than any signal could travel. Einstein called it spooky action at a distance, yet experiments repeatedly confirmed it. The machine no longer had clearly separated parts. Everything was interconnected. These insights not only called into question physical models, but also the entire metaphysical foundation of modernity. If space and time are not fundamental, if objects possess no fixed properties before they are measured, and if separation is an illusion, what remains of the mechanical worldview? The answer was uncomfortable. It crumbled. Classical physics remained valid for many applications. Machines function. Rockets fly. Computers compute. Yet at the deepest level of reality, the image of dead, isolated matter was no longer tenable. Instead, a world emerged that was relational, dynamic, and open. Another crucial point was the role of development. The mechanical worldview assumed timeless laws governing an unchanging reality. However, modern cosmology painted a different picture. The universe had a history. It had a beginning. It evolved. Structures formed, changed, and disappeared. Galaxies took shape. Stars were born and died. Chemical complexity increased. From simple matter, life emerged. From life, consciousness arose. The universe was not a static system. It was a process, and processes cannot be fully captured by mechanical metaphors. For machines are built, processes unfold, Machines follow external purposes. Processes carry their own dynamics within themselves. The deeper the research went, the clearer it became. Reality behaves less like a clockwork and more like an evolving whole. This realization led to a paradigm shift that extended far beyond physics. In biology, the exploration of self-organization began. In chemistry, it was recognized that order could arise spontaneously. In systems theory, it became evident that complex structures emerge from simple rules, without a central plan. Order no longer required an external clockmaker. Thus, the old notion of a purely deterministic universe also lost its power. Indeed, there are laws, yet they do not dictate a single future. Possibilities branch out, probabilities replace certainties. Creativity takes the place of mere repetition. The mechanical worldview had promised to explain everything, yet it could neither integrate consciousness nor explain development without contradicting itself. It had disenchanted the world, but in doing so it lost its depth. Now it became clear. This disenchantment was not the end of the story, but rather an intermediate step. The collapse of this worldview did not signify the failure of science, quite the opposite. It marked its maturation, for true knowledge recognizes its own limits. It does not regard models as the reality itself, but as tools, and the tool machine had become too coarse. In its place arose no finished new dogma, but an open question. If the universe is not a machine, then what is it? A collection of relationships? A field of possibilities? A self-organizing whole? One thing was certain: separation, isolation, and meaninglessness were not necessary properties of reality, but assumptions of a particular worldview. With the collapse of the mechanical model, a space opened up for new metaphors that take interconnectedness seriously, that understand development as central, and that allow for the possibility that consciousness does not randomly emerge at the periphery, but is deeply rooted in the fabric of reality. This transformation did not occur abruptly. It unfolded over decades, often against resistance, yet it was irreversible, for the facts could no longer be forced into the old image. The universe was no longer a cold clockwork ticking away blindly. It was a dynamic, interwoven happening, a becoming rather than a being. And precisely in this becoming, a question arose that the mechanical worldview could never answer. Why is there experience at all? With this question began the next great upheaval. For where matter ends, consciousness begins. And it is precisely here that the greatest blind spot of modern science became evident. The collapse of the mechanical worldview was therefore not the end of an era, but the gateway to a deeper, more radical understanding of the true nature of reality. The deeper science penetrated into the structure of the universe, the clearer a paradoxical problem emerged. We could map galaxies, dissect particles, mathematically describe space and time, and yet something utterly unexplained remained, something that underlies all cognition: consciousness. Ironically, the phenomenon without which there would be no science at all remained the greatest blind spot of science itself. For however successful physics, chemistry, and biology were in explaining the outer structures of the world, they failed at a seemingly simple question: why does existence feel like something? A stone exists, an atom exists, a star exists, but only certain arrangements of matter experience their existence. Why? The classical materialistic answer for a long time was: consciousness is a byproduct, an epiphenomenon, a random result of complex brain processes. Once nerve cells surpass a certain threshold, consciousness emerges, much like heat arises from friction. Yet it is precisely here that the problem begins. For even if we could fully map every neural activity in the brain, a crucial gap would remain. We could explain what happens in the brain, but not why subjective experience arises from it. Why there are colors, feelings, pain, joy, meaning. This gap is not technical, it is fundamental. And then the philosopher David Chalmers gave it a name, the hard problem of consciousness. It refers to the fact that there is no known way to derive subjective experience from purely objective physical processes. No equation, no model, no algorithm explains why activity feels like something from the inside. One can describe how light of certain wavelengths hits the retina. One can explain how signals are processed in the brain. But none of this explains why it results in the experience of red. The mechanical worldview can explain functions, but not experience. For a long time, this problem was sidestepped. Consciousness was reduced, ignored, or labeled as an illusion. Yet this strategy came at a cost. To call something an illusion already presupposes consciousness. An illusion is always an illusion for someone. As neuroscience advanced, it became increasingly clear. The brain does not explain consciousness, it correlates with it. There is a connection between neural states and subjective states, but no explanation in a deeper sense. This led many researchers to a radical rethinking. What if consciousness does not arise from matter, but rather the other way around? What if consciousness is not the latest product of cosmic evolution, but one of its prerequisites? This question had long been taboo. It reminded too much of old metaphysical concepts, of idealism, of spirituality. Yet it returned, not out of belief, but out of logical necessity. For if consciousness is real, and there is no doubt about that, then it must be anchored somewhere in the foundation of reality. A worldview that cannot integrate consciousness is incomplete. Some philosophers and physicists began to shift their perspective. They no longer asked, how does consciousness arise from matter? Instead, they asked, what must matter be for consciousness to be possible? This reversal led to new lines of thought. One of them is the idea that the physical description of the world captures only its outer structure, not its inner nature. The equations of physics tell us how things behave, but not what they are. The physicist Arthur Eddington articulated this as early as the 20th century. Science describes the world from the outside, yet it says nothing about its inner essence, and it is precisely there that consciousness might be situated. The philosopher Bertrand Russell picked up this thought and developed a position now known as Russellian monism. It states, matter has an inner side, and this inner side could be consciousness-like, not in the sense of human thoughts or feelings, but as an elemental form of experience. This idea later became known under the term panpsychism, not as an esoteric claim but as a serious philosophical option. It does not assert that stones think, but that the fundamental building blocks of reality possess an inner dimension from which complex consciousness can emerge. Thus, consciousness would not suddenly appear out of nothing, but would organize gradually, similar to complexity, life, or order. Many find this thought unsettling, yet it resolves a central problem. It explains why consciousness exists in the world at all, without assuming a magical leap between matter and mind. Concurrently, a growing discomfort with a purely objective worldview also developed in physics. Quantum physics had already shown that observation does not play a passive role. Information and measurement are not merely ancillary aspects. They are fundamental. Some physicists began to regard information as more fundamental than matter, and others went even further and saw consciousness as an indispensable component of any complete description of reality. The physicist John Wheeler articulated the provocative idea of a participatory universe. In this view, the universe is not independent of the observer. Reality emerges from the interplay of structure and experience. Observers are not mere spectators, they are co-creators. This radically shifts the role of consciousness. It is no longer a random byproduct in an otherwise meaningless cosmos. It becomes the key through which reality takes shape at all. This perspective is supported by another observation. The universe is astonishingly comprehensible. Mathematical structures that arise in the human mind precisely describe the deepest laws of nature. Why should a random, lifeless universe be comprehensible to conscious beings? Albert Einstein referred to this comprehensibility as the most incomprehensible thing about the universe. Some researchers therefore suspect that consciousness and cosmos are related on a deeper level, not by chance, but structurally. The universe seems to produce conditions under which it can be recognized, and with recognition comes meaning. Herein lies the reason why consciousness has been the blind spot of science. Not because it is unimportant, but because it is too fundamental to be captured within a purely mechanical framework. Anyone who explains consciousness must also explain why there is anything at all that can be explained. Thus, consciousness moves from the periphery to the center, not as a mystical appendage, but as a serious dimension of reality, as something that cannot be ignored or dismissed without distorting the entire worldview. This realization compels a re-evaluation of what the universe is. If consciousness is fundamental, then reality is not merely a collection of things, but a field of experiential possibilities, a space in which experiencing is possible. The universe would then not just be a place where consciousness randomly appears, it would be a cosmos that bears consciousness. And it is precisely at this point that the next perspective opens up. For if consciousness is not foreign to the universe but part of its structure, then the metaphor with which we grasp the whole changes as well. The machine is no longer sufficient. What is instead suggested is an image of the universe as something alive, as a self-organizing, self-generating whole in which consciousness is not a flaw, but an expression. Thus, we enter the next stage of this thinking, for perhaps the universe is not just the place where life arises. Perhaps it is itself, on a deeper level, alive. When the mechanical worldview reaches its limits, space opens for a new metaphor, not as a poetic substitute, but as a necessary tool for thought. Just as every era had its preferred language for describing reality, our time demands a new framework to comprehend what we have come to see. The machine was a powerful metaphor. It enabled control, calculation, prediction. Yet it never explained why order arises, why complexity grows, why newness continually emerges from simple initial conditions. The more precisely we examine the universe, the less it resembles a clockwork, and the more it resembles an organism. An organism is not an object controlled from the outside. It is a process. It organizes itself, responds to its environment, regulates itself, evolves, and brings forth new structures from within. Its order does not arise despite the chaos, but through it. And it is precisely these qualities that we are beginning to recognize today in the cosmos. The universe is not static. It evolves. It is not randomly disordered. It forms structures. It is not passive. It brings forth complexity. From the Big Bang to the formation of galaxies, stars, planets, life, and consciousness, a continuous trend can be observed. Matter organizes itself repeatedly into higher orders, not through external interventions, but from inner dynamics. This self-organization is one of the strongest indications that the machine metaphor is inadequate. In classical physics, order was considered something imposed. Machines function because someone builds them. Their goals lie outside of themselves. An engine does not know why it turns. It follows an alien intention. Organisms, on the other hand, carry their purpose within. They sustain themselves, they react, they learn, they adapt. Their order is not imposed. It is immanent. When we now observe the universe, we see a system that becomes more complex without an external designer. Galaxies form from chaotic distributions of matter. Stars are born, live, and die. Chemical elements are created within them and later passed on to new systems. Planets form. On some of them, stable information processing structures emerge. Life. None of this was planned from the outside. Everything follows inner laws, yet these laws seem to be geared towards unfolding. Modern sciences such as thermodynamics, far from equilibrium, complexity research, and systems theory show that order under certain conditions is not the exception, but the rule. Open systems that exchange energy tend to organize themselves. They form patterns, cycles, hierarchies. The universe itself is such an open system, at least in its local dynamics. It is permeated by flows of energy, streams of information, and interactions on all scales. Information plays a key role in this. In the machine metaphor, information is a byproduct. In the organismic view, it becomes fundamental. Systems store information, process it, respond to it. From the genetic code to neural networks, a consistent principle emerges. Reality organizes itself through carriers of meaning. Even physical laws can today be understood as informational structures. Some physicists speak of information being more fundamental than matter. Matter would then be a form of stabilized information, a condensation of relationships. An organism is precisely that, a network of relationships that sustains itself. The universe also exhibits these qualities. It is not a loose aggregate of things, but a coherent whole. Every region is related to every other, through gravity, quantum entanglement, causality, and history. The past of the universe has not vanished. It is inscribed in its present, in the elements of our bodies, in the structure of galaxies, in the background noise of the cosmos. Like an organism, every cell carries the history of the whole within it. This self-similarity across scales from particles to galaxies echoes biological patterns, fractal structures, networks, feedback loops. Nature seems to generate new forms repeatedly with a few principles. Development is not a random wandering. It follows paths. Possibilities open up, others close. There is stability in breaks, phase transitions, and creative leaps. This is precisely what we observe in cosmic evolution. Long phases of relative stability are interrupted by upheavals. New orders emerge, old ones decay. Stars explode to create heavier elements. Catastrophes are part of the system's creativity. And in a purely mechanical universe, such developments would be difficult to explain. Machines wear out, organisms regenerate. The cosmos seems to do the latter. Yet to be alive does not mean that the universe is a vast animal or a thinking being in the human sense. It does not imply that it pursues a conscious intention. The organismic metaphor describes not a person, but a process. A living system is one that brings itself into being, one whose order arises from within, one in which parts only make sense in relation to the whole. In this sense, the universe can be understood as alive, not biologically, but ontologically. This perspective has far-reaching consequences. It alters how we comprehend causality. In machines, cause flows linearly from A to B. In organisms, feedback loops exist. Effect becomes cause. Systems influence themselves. We observe such circularity in the universe as well. Structures influence the conditions of their own emergence. Galaxies shape the fabric of space-time, which in turn guides their development. Life transforms planets, which in turn shape life. Particularly remarkable is the role of consciousness. If consciousness, as shown in the previous chapter, is not mere coincidence but a fundamental property of certain levels of reality, then it is part of this organismic process. Consciousness would not be foreign to the universe, but one of its expressions. An organism that produces consciousness begins to reflect upon itself. Within us, the universe becomes not only complex, it becomes aware of itself. Not as a whole, but fragmentarily, locally, provisionally. Yet, it is real. This imparts a new dimension to evolution. It is not merely a sequence of physical states, but a narrative of increasing interiority. Matter organizes itself into life, life into sensation, sensation into self-awareness. Consciousness need not appear as a sudden miracle. It can be understood as a continuous deepening, an increasing capacity of the universe to experience itself. This perspective connects modern science with ancient intuitions. Many cultures have felt the world as alive, not out of naivety, but from experience. The difference from earlier animistic notions lies in the fact that we now know the physical structures in which this aliveness occurs. The organismic perspective does not replace science. It integrates it. It acknowledges the mechanical aspects without absolutizing them. Just as an organism consists of chemical processes without being reduced to chemistry, so too can the universe be described physically without being reduced to mechanics. Machines can be completely dismantled. Organisms lose their essence in the process. Perhaps the same holds true for the universe. If we merely break it down into parts, we lose sight of what connects them, of the process that underpins everything, of the dynamics that shapes meaning from chaos. The universe as a living organism is therefore not a romantic fantasy. It is a serious attempt to do justice to the observed reality, one that grows, organizes, carries meaning, and enables consciousness. And if this is true, then we are not foreign bodies in a dead cosmos. We are part of a living whole that unfolds further through us. Yet this realization raises an even deeper question. If the universe is alive, who are we really? This question leads us to the next chapter. If the universe is not a dead space but a living, evolving process, then an inevitable question arises that reaches deeper than any scientific theory. Who are we in such a cosmos? For centuries, modern science has systematically decentered the human self-image. We are not the center of the universe, not the purpose of creation, not even something special on a cosmic scale, a planet among billions, a species among countless possible forms of life, a moment in the flow of time. These realizations were correct, and yet incomplete, for they answered a false question. They inquired about our spatial significance, not our ontological role, about position, not function, about size, not depth. In a mechanical universe, meaning is tied to size. A gear is replaceable. A part has no intrinsic value but serves only the whole. And even that whole has no inner purpose. It runs until it stops. Yet in a living universe, different rules apply. An organism measures meaning not by size but by relationship. A single nerve cell is tiny and yet indispensable for the experience of the whole. A leaf is small and yet an expression of the entire plant. In living systems, every part is simultaneously locally limited and globally significant. If the universe is such an organism, then we are not mere spectators. We are participants, not by chance, but by necessity, not as the center, but as expression. The phrase, "we are stardust," was an important step. It connected us physically to the cosmos. The elements of our bodies were forged in stars. Our atoms have a cosmic history. Yet this phrase falls short today, for we are not only made of stars, we are also bearers of consciousness, that quality which gives the universe its meaning. Without consciousness, there would be no experience, no values, no inner life, no perspective. A universe without consciousness would not be empty, it would be meaningless. Meaning arises only where something is experienced, and it is here that our identity shifts fundamentally. If consciousness is not a byproduct, but a fundamental aspect of reality, then conscious beings are not mere anomalies. They are key phenomena. In them, cosmic evolution reaches a new quality, the ability for self-perception. The cosmos sees itself through us. This idea is not new. Carl Sagan articulated it when he said that humanity is a way for the universe to know itself. Yet for a long time, this statement remained metaphorical. Today, it gains ontological depth. For if consciousness is real, not reducible, not illusory, then it is a place where reality reveals itself from within. Within us exists not only matter, but experience. Not only movement, but meaning. Our thoughts, feelings, and perceptions are not mere epiphenomena. They are expressions of a deeper principle, the ability of reality to experience itself. This radically alters the question of identity. We are not merely human. To be human is a form, a temporary configuration, a biological manifestation. Yet beneath lies something more general. We are consciousness in individual form. This consciousness is locally limited, bound to a nervous system, and yet it carries universal properties. It is the same capacity for experience that arises wherever complexity and organization surpass certain thresholds. In this sense, we are not isolated islands. We are windows through which the universe gazes upon itself. Each consciousness is a unique viewpoint, a distinct perspective on the same whole. This leads to an idea that many find unsettling. Identity is not absolutely separate. It is relational. We are separated in bodies, yet connected at the core of experience. Philosophers refer to this perspective as open individualism. It does not claim that we are all the same, but rather that we are all expressions of the same conscious ground, differentiated, individualized, contextualized. In such a model, separation is real, but not absolute. Diversity is genuine, yet not isolated. The self is not an illusion, but it is also not the ultimate reality. This perspective profoundly alters ethics. If other conscious beings are not foreign objects, but alternative expressions of the same fundamental principle, then compassion becomes not a moral obligation, but a logical consequence. Harm to others is harm to a system of which one is a part. Cooperation is not idealism, but an evolutionary necessity. In a living universe, competition is merely a phase, not the goal. Responsibility also takes on a new dimension. In a mechanical cosmos, one can hide. One is a product of chance, without purpose, without meaning, without responsibility beyond one's own survival. In a living cosmos, that is not possible. If consciousness is a central expression of reality, then every conscious being bears responsibility for the quality of experience it brings into the world. Thoughts, actions, decisions are not private. They influence the network of which we are a part. This does not mean that we are chosen. It means that we are involved. Our identity thus shifts from an isolated self to a relational existence. We are nodes in the fabric of the cosmos, places where information, experience, and meaning converge. This perspective can be frightening. It strips away our excuse of insignificance. It demands maturity, mindfulness, responsibility. But it also returns something that was lost in the mechanical worldview, meaning, not as a predetermined answer, not as dogma, but as an open possibility. Meaning arises where consciousness becomes aware of itself and begins to act with intention. We are not here to fulfill something that lies outside of us. We are here because the universe has reached a new capability within us, the ability for self-reflection, and perhaps that is precisely our role. Not as rulers over nature, not as victims of a cold cosmos, but as conscious participants in an unfolding whole. Our identity is neither small nor great, it is profound. We are expressions of a universe that is alive, a universe that organizes itself, a universe that is beginning to understand itself. And if that is true, then the question is no longer whether our lives have meaning. The question is how we shape that meaning. For within us, the universe begins to take responsibility for itself. This opens the space for the final reflection. What does it mean for your life, if the universe is not cold but alive, if consciousness is not chance but foundation, and if you are not outside of it but a part of it? These questions lead us to the end of our journey and at the same time to its beginning. Hassan, perhaps the greatest misunderstanding of our time has never been the question of God, but rather the assumption that the universe is indifferent, a cold space, an empty nothingness, a machine without purpose. But what if that is precisely wrong? What if the universe is not a dead backdrop, but a living process, unfolding, organizing, learning for billions of years, and at some point began to experience itself? In this vision, you are not a coincidence, not a meaningless observer, not a speck of dust without a voice. You are consciousness in individual form, a place where the universe feels, thinks, questions, a nexus where experience arises. If consciousness is indeed a fundamental principle of reality, then meaning does not end with religions or ideologies. Meaning begins where perception takes on responsibility, then every decision matters. Every thought is a contribution. Every action is part of a larger context. Not because someone is watching, not because something is being directed, but because you are part of what is happening. Perhaps the universe is not here to be understood like a machine. Perhaps it is here to be experienced, and maybe that is its deepest movement, to recognize itself through countless perspectives, through stars, through life, through you. The old question was, what is the universe? The new question is more personal, more uncomfortable, and more honest. What will you make of your role when you realize that the universe is conscious through you, spirit to spirit?